Knowing 9 intestinal health markers found in your poo could save your life. I have analysed several hundred stool samples over many years from people from all walks of life and with many different health issues. And there are 9 intestinal health markers which can identify how healthy your gut health is or isn't. Now, these 9 intestinal health markers found can identify everything from your ability to digest food, how well you detoxify hormones and toxins, how much blood is in your stool, how well 70% of your immune system is functioning, which resides in your gut. Are you sensitive to gluten? How much inflammation is in your gut, and also how leaky your gut is. Now, knowing all this can have a huge impact on your health, both physically and mentally. If your gut isn't healthy, neither will you be. As the Greek philosopher Hippocrates said, all disease begins in the gut, and I have to agree with that. Now, I want to go through each one of these 9 intestinal health markers so you really understand the importance of these markers and what they can tell you about your gut health. Okay, so the first gut marker we're going to look at is something called steatocrit, which is how well we digest fat. Now, steatocrit is a diagnostic test specifically designed to measure the fat content in our stool, offering a non-invasive method to evaluate fat malabsorption. Now, stool fats are normally emulsified by bile salts and absorbed in the small intestine. High levels of fat in the stool may be an indication of maldigestion and malabsorption. Now, some causes of elevated steatocrit are things like, and that can cause that is hyperchlorhydria, which is low stomach acid, maldigestion, malabsorption, pancreatic insufficiency, and bile salt insufficiency. And fat malabsorption then affects the absorption of fat in the small intestine, and it's one of the most common types of malabsorption. High steatocrit levels typically signal that the digestive system is unable to break down and absorb dietary fats efficiently, leading then to nutritional deficiencies and other related symptoms like weight loss, diarrhea, and abdominal discomfort. Gut marker number 2 is also to do with digestion, and it's also looking at something called pancreatic elastase 1. Elastase 1 is a digestive enzyme secreted exclusively by the pancreas, giving a direct indication of pancreatic enzyme function. So pancreatic elastase 1 is also a non-invasive, easy way to look at pancreatic function from an enzyme perspective. Low levels have been associated with poor pancreatic function, gallstones, cystic fibrosis, and hypochlorhydria, which, as I said, is low stomach acid. The pancreas is a gland, sits behind the stomach. It produces elastase and other juices that help with digestion. Conventionally, pancreatic elastase has been of interest primarily in the context of pancreatic disease, particularly chronic pancreatitis. Chronic pancreatitis is a long-term inflammation of the pancreas, which can then lead, as you'd expect, to impaired pancreatic function. In adults, pancreatic insufficiency is often a sign of chronic pancreatitis. Pancreatitis is an inflammation of the pancreas. Chronic pancreatitis is a long-lasting condition that tends to get worse over time. It can lead to permanent damage of the pancreas. So low pancreatic elastase levels could mean someone has what is known as exocrine pancreatic insufficiency. Any disease that affects pancreatic tissue can cause exocrine pancreatic insufficiency. And the most common cause in the UK is cystic fibrosis, acute pancreatitis, chronic pancreatitis, and pancreatic cancer. 8 out of 10 individuals with chronic pancreatitis will eventually develop exocrine pancreatic insufficiency. So what exactly is pancreatic and exocrine pancreatic insufficiency? When the pancreas is healthy and functioning normally, it produces many enzymes, which are simply a group of proteins that aid in the process of digestion. These enzymes are secreted into the small intestine, where they work then together to digest food, your proteins, your fats and carbs. In individuals with pancreatic exocrine insufficiency, the pancreas doesn't make enough of these enzymes to adequately break down food into their absorbable components, and then, as you'd expect, this can lead to nutritional deficiencies. In a damaged pancreas, either not enough enzymes are produced or the pancreatic duct is blocked, or both can happen sometimes. If not enough enzymes reach the top of the small intestines, the nutrients in food then will not be digested. They will continue to travel along the small intestines. When they reach the large intestine, the nutrients then can produce unpleasant symptoms such as diarrhea. So the gut bacteria also then use the undigested nutrients for energy, and this can cause abdominal pain, flatulence, and bloating. This process is where the nutrients are not absorbed, is also known as malabsorption. Exocrine pancreatic insufficiency can also lead to many other complications, including, as we've seen, malnutrition due to malabsorption, osteoporosis, immune system weakness, also then the inability to digest fat-soluble vitamins like A, D, E, and K, and essential fatty acids like the omega-3s into the body. And also there is a higher risk then for heart attack, stroke, and other cardiovascular conditions. So what levels of pancreatic elastase is optimum? Levels below 200 may indicate exocrine pancreatic insufficiencies. See it all the time. Levels between 2 and 500 is showing a decreased pancreatic output, and levels above 500 indicate expected pancreatic function. So let's now look at another gut marker called beta-glucuronidase. And beta-glucuronidase is an enzyme that is produced by the colonocytes and by some intestinal bacteria. Beta-glucuronidase is an enzyme that unconjugates or unlinks chains of molecules, and high levels can indicate several problems. So the gut microbiome plays a critical role in the regulation and metabolism of hormones, including estrogen and progesterone. Now, the subset of gut microbiota, also known as the estrobolome, is specifically involved in the metabolism of estrogens. These bacteria produce beta-glucuronidase, which, as I've just said, is an enzyme that can deconjugate estrogens and convert them back then into their active form. If beta-glucuronidase activity is too high, it can lead to the reabsorption of estrogens from the intestines into the bloodstream, which can then disrupt hormonal balance and contribute to conditions like estrogen dominance. Again, I see this on a very regular basis. High estrogen toxicity can have a range of health impacts and can be influenced by various factors, including by the enzyme beta-glucuronidase. In the presence of beta-glucuronidase, the conjugated, which is bound estrogen molecules, are broken down into their parts and then reabsorbed into the bloodstream via the portal vein, returning to the liver. The liver then reconjugates, which binds up these estrogen molecules and sends them back to the small intestine for elimination with the help of bile from the liver. However, beta-glucuronidase in the intestine can again break the estrogen down again, allowing it to return to the liver once more. And the same process can affect various toxic substances, making it difficult for the liver to eliminate them. Consequently, the presence of this enzyme can lead to persistent estrogen dominance and elevated toxicity levels. There is also some evidence linking elevated beta-glucuronidase levels with an increased conversion of pro-carcinogens into active carcinogens in the gut, raising the risk of colorectal cancer. Beta-glucuronidase levels can also reflect liver function and overall detoxification and capacity, providing insights into the body's ability to process and eliminate toxins. Now we're going to look at something known as the fecal occult blood test. The main use of this test is to screen and investigate for bowel cancer. It is uncommon for early colorectal cancers to have signs and symptoms, but one of the simplest tests used to determine if there's an abnormality in the colon is a fecal occult blood test, also known as FOBT or abbreviated, that detects hidden traces of blood in your stool. However, recent studies have demonstrated this invisible blood may also be linked to a heightened risk of death from all causes. The occult blood test in your stool therefore may offer a window into your health. Even when blood is not visible to the naked eye in your stool, it can signal the presence of other potentially fatal health conditions other than colon cancers. Researchers found those who had trace amounts of blood in their stool had a 58% higher risk of premature death from a variety of causes. So blood in the stool may be the only symptom of early cancer. If the cancer is detected before it metastasizes, spreads to other areas of the body, there is a greater chance it can be treated successfully. Now, a positive fecal occult blood test does not necessarily prove that you have cancer. There are other possible causes of bleeding, and other follow-up procedures will need to be done to find the source of the bleeding. So research suggests a result of 10 UG and above may be indicative of potentially more serious conditions, such as things like polyps or colorectal cancer. But a variety of ailments can also cause blood in the stool, such as hemorrhoids, anal fissures, as I just mentioned, intestinal polyps, pathogenic infections, liver diseases, and upper GI infections. And again, I've seen that also. Now let's look at secretory immunoglobulin A. Now, firstly, did you know that over 70% of your immune system actually resides in your gut? And it is our body's first line of defense against pathogens. Now, secretory immunoglobulin A is the main immunoglobulin produced by the gut mucosal immune system to help stop intruders from harming the body. Disruptions in our gut mucosa and low levels of secretory immunoglobulin A can lead to infections, food sensitivities, gastrointestinal diseases, autoimmune conditions, and more. So B cells from the immune system produce secretory immunoglobulin A, which, as I've said, acts as the first line of defense against the entry of foreign substances into the body. And these foreign substances, it could be undigested proteins from foods we eat, bacteria, viruses, parasites, or mold. And secretory immunoglobulin A will give us an insight into mucosal tolerance. If you think about it, the body's mucosal surfaces, which are the eyes, the ears, the nose, the throat, the sinuses, skin, vaginal tract for females, urinary tract, and GI tract, are all entry points for various disease-causing pathogens. And our body's way of protecting these points of entry is done with the release of secretory immunoglobulin A. It simply attaches itself to invading bacteria, viruses, and other foreign substances. And once attached, it can trap the invader in the mucosal surfaces, and from there, it can neutralize the threat. So normal levels of secretory immunoglobulin A, that they indicate a well-functioning immune response and a healthy mucosal barrier, reflect a balanced interaction between the immune system and the gut microbiota. What does a low SIG-A actually mean? Low secretory immunoglobulin A levels are a sign then of chronic stress in the body that has drained the immune system. And if your secretory immunoglobulin A is low, this means that you are less able to prevent invaders from getting into your gut mucosal lining. This lining then can become inflamed, and tight junctions that ordinarily keep toxins and undigested food particles out actually break down. And then this causes havoc, as now toxins, undigested substances are able to get access to our bloodstream, causing inflammatory and immune reactions that lead to systematic symptoms throughout our body. Patients with low secretory immunoglobulin A levels generally have increased risk of food sensitivities, irritable bowel syndrome, inflammatory bowel disease, intestinal permeability, also known as leaky gut, autoimmunity, and other gastrointestinal infections. And high levels of secretory immunoglobulin A, what do they indicate? They can indicate an activated immune response to some sort of infection, stressor, or acute inflammatory response. The high secretory immunoglobulin A could also indicate a viral infection such as Epstein-Barr virus or some other kind of infection. Now let's look at another immune response marker in our gut, and it's called anti-gliadin immunoglobulin A. Now gliadin is a component of gluten, the protein found in wheat and other field grass grains such as barley, malt, and rye. The presence of fecal anti-gliadin antibodies can indicate an immune response in the gut to gluten from the diet. Fecal anti-gliadin antibodies do not necessarily correlate with blood levels. And we also have another gut marker that can represent our immune response called eosinophil activation protein. Now, eosinophil activation protein is a protein released, as you would expect, by the eosinophils, which is a type of white blood cell that plays a crucial role in the body's immune response to allergies, infections, and inflammatory conditions. Elevated eosinophil protein in stool can offer variable insights into gastrointestinal health. Elevated eosinophil protein is one of the potent proteins released by eosinophils serving functions that include antimicrobial actions and inflammation mediation. Examining eosinophil activation protein levels in the stool test is particularly useful for diagnosing and monitoring gastrointestinal disorders where eosinophils play a role. Understanding this level can offer insights into diseases affecting the gastrointestinal tract, often linked to inflammation and allergic reactions. And one of the most well-documented causes of eosinophilic gastroenteritis is food allergies. Foods such as dairy, eggs, soy, wheat, nuts, and seafood can trigger an immune response that then leads to eosinophil accumulation in the gastrointestinal tract. And these allergic reactions can cause inflammation, result in symptoms such as dermatitis, abdominal pain, nausea, to severe gastrointestinal discomfort. In addition to food allergies, environmental allergens like pollen, dust mites, mold, can also induce eosinophils levels on a high levels in susceptible individuals. Parasitic infections, particularly helminths, which are parasitic worms, are also known to induce eosinophil proliferation. As the body attempts to combat these infections, eosinophils will infiltrate infected tissues, including the gastrointestinal lining, leading to inflammation and other symptoms associated with gastroenteritis. Now, another very important gut marker to look at is something called calprotectin. Calprotectin is a protein released by a type of white blood cell called a neutrophil. When there is inflammation in the gastrointestinal tract, neutrophils will move to the area and they release calprotectin, resulting in an increased level in the stool. Now, fecal calprotectin is the most studied marker of gastrointestinal inflammation. High calprotectin levels indicate neutrophil infiltration to the gut mucosa. Calprotectin is the gold standard marker for the diagnosis and monitoring of inflammatory bowel disease. It is used to differentiate irritable bowel disease from irritable bowel syndrome. And according to a 2011 study, what they found is that this test is very important for the diagnosis of irritable bowel disease. High levels may also indicate inflammatory bowel disease, but also help to differentiate, as I've just said, from irritable bowel disease and irritable bowel syndrome. Elevated levels of calprotectin around 250 to 300 or above is a red flag and an indicator of irritable bowel disease, and I see it regularly. Food allergens, polyps, infections, diverticulitis, colorectal cancer may also cause high calprotectin levels. Anything that causes inflammation in the intestine can cause an increase in stool calprotectin. What do the results mean? So a normal fecal calprotectin range is generally below 50, indicating no significant gut inflammation. Levels of 100 to 200, that can suggest inflammation needing further investigation. Okay, we know that levels then over 250 strongly points to other more inflammatory diseases like irritable bowel disease or infection. Now, our last gut marker to look at is zonulin. Now, zonulin is a protein that plays a crucial role in regulating the permeability of the intestinal barrier, which consists of a single layer of epithelial cells held together by structures known as tight junctions. Now, tight junctions regulate what passes from the intestine into the bloodstream, ensuring that harmful substances are kept out while allowing nutrients and beneficial compounds to pass through. How zonulin works. Tight junctions act as the gatekeepers between the cells lining the gut, controlling the passage of nutrients, ions, and water. Zonulin controls these junctions by loosening them, thereby regulating the permeability of the intestinal epithelium. Under normal circumstances, this regulation is crucial for nutrient absorption and immune function. Once released, zonulin binds to specific receptors on the surface of intestinal epithelial cells, initiating a signal cascade that results in the disassembly of the tight junction proteins. As a result, the spaces between the intestinal epithelial cells widen, increasing intestinal permeability and allowing various substances, including undigested food particles, toxins, pathogens, to pass from the gut lumen into the bloodstream. Now, certain triggers such as gluten, infections, and inflammation can stimulate the release of zonulin in the intestine. When someone has elevated zonulin levels, they will often suffer from multiple food sensitivities, food allergies, chemical sensitivities. Gluten is one of the most well-known triggers of zonulin release. Persistent intestinal permeability can contribute to chronic inflammation, which is linked to various health conditions such as autoimmune diseases, things like celiac disease, type 1 diabetes, multiple sclerosis, metabolic disorders like obesity, insulin resistance, inflammatory bowel disease, things like Crohn's disease, ulcerative colitis, allergies and asthma, and mood disorders. So hopefully you now understand how important these 9 intestinal health markers are, which can be found on advanced stool tests like the GI map stool test, which is the one that I use, and how incredibly beneficial they are on assessing your gut health.